We introduced the idea of ground and excited states when looking at the spectrum of hydrogen, which led to the Bohr model of the atom. We also have the concept of ground and excited states in the quantum model. When all electrons are placed in the lowest energy orbitals available, the configuration is called the ground state. The diagram on the left is for a neutral carbon atom, which has 6 electrons. Since all of the electrons are in their lowest possible orbitals, and the 2 electrons in the 2p sublevel obey Hund's rule, this is the ground state of carbon. Of course, 6 electrons can be distributed in a variety of ways, so there are a variety of excited states, one of which is shown on the right. Notice that an electron has been promoted from the 2s to the 3s orbital. Yes, it has also changed its spin, but the mere fact that the 2s orbital is half-filled and there are electrons in higher energy orbitals tells us this is an excited state. Here we see 4 different energy level diagrams. They all have 14 electrons, so, assuming that they are all for a neutral atom, they are all diagrams for silicon. The diagram on the left is the ground state. All of the electrons are in their lowest energy orbitals available, and the 2 electrons in the 3p sublevel follow Hund's rule. The second diagram is an excited state. An electron has been promoted from the 3s to the 4s orbital. We surmise that it has also flipped its spin, but the fact that there are electrons in higher energy orbitals while 3s is half-filled means that this is an excited state. Don't be distracted by the fact that moving the 4s electron back down to 3s with the spin shown would not be allowed. Spin flips represent an absorption or emission of energy as well. This is seen in the fourth diagram. All of the electrons are in their lowest energy orbitals, but the electrons in 3p do not follow Hund's rule. The first diagram, with electrons obeying Hund's rule by spreading out with the same spin, is in fact lowest energy. The fourth diagram, where there is a spin flip, requires energy and is therefore an excited state. The third diagram is also an excited state. The 2 3p electrons are now in the same orbital. We can understand this based on Coulomb's law. When 2 electrons with the same negative charge are moved closer together into the same space, that would be higher energy. They would prefer to spread out away from each other in different orbitals.